Students, in this video I am going to discuss preservation of interval theorem and then uniform continuity. So first, the statement of this theorem, preservation of interval theorem. The image of a closed interval under a continuous function is a closed interval. That means if we have domain as a closed interval and function is a continuous function, then the image of this function is also a closed interval. This is the theorem. Fine. So we have to prove this. So suppose we have a function f from closed interval ab. So you can see that domain is a closed interval and it's a real valued function, so image will be r, set of real numbers. So this will be a continuous function in the closed interval AB. Then our purpose is to show that the image of this function is also a closed interval. Then we have to show that f of AB, that means the image of this closed interval under f, which is nothing but collection of the points of the form f of x. ये इस टाइप के पॉइंट्स होंगे where x varies from a to b, closed interval a to b is a closed interval. We have to prove that. That means we have to prove that f of ab is basically a closed interval. We have to prove this. Graphically you can see, this is suppose our function, this is our function f, then this is the domain from a to b, closed interval a to b, this is closed interval a to b. Then its image is basically from here, this is the lowest point and this is the highest point. So image is basically small m to capital M. So we have to prove that this from m to m, this is a closed interval. We have to prove this. This is our target. Fine. So how to prove this? Let's see. So since function is continuous in the closed interval AB, this is already given to you. Then we have already proved one theorem in previous lecture. If a function is continuous in a closed interval AB, then it attains its supremum and infimum at least once. That means function is bounded. Fine. So function is bounded. This is already proved here. Function is continuous in the closed interval, then it is bounded. And since bounded, so attains its supremum and infimum at least once in this interval. We have already proved these two theorems in previous lectures. So we will use those theorems. So since function is continuous in closed interval, then it is bounded and attains its bounds. That means supremum and infimum in AB, according to these two theorems which we have shown here. So suppose small m is the infimum, that means this point, and capital M is the supremum of f, that means this point. So supremum is this highest point and infimum is the lowest point, according to this graph. So we have to prove that f of AB is basically this closed interval small m to capital M. We have to prove this. This is our target. Fine. Now, since m is the infimum and according to this, function attains its bounds in closed interval AB. So that's why if m is infimum of f, then we can find some alpha on this domain so that f of alpha is small m. Similarly, for this capital M, we can find, which is nothing but the supremum, we can find a point beta on this domain a to b such that f of beta is m. So f of alpha is m, f of beta is m. So that means from this we can find, because if you will see that m is the infimum and capital M is the supremum, so obviously f of x laying in between these two, and this is our target. So from this equation number 2, we can say that there exists alpha and beta because function attains its bounds. That's why alpha and beta, they will be there, 2 points. We can easily find out those points such that f of alpha is small m and f of beta is capital M. But now here is a question, because here we have shown our function is of this form. Here is A, here is B, and this point we have assumed as alpha, and this point we have assumed as beta. But this may be possibility that function is of this form. This is b, this is a, and according to our assumption, supremum is capital M. So this is supremum, capital M, and this is the infimum point, small m. And in that case, we have assumed that f of alpha is small m. F of alpha is small m. So this is basically alpha, and this will be beta. However, in this assumption, what we have taken, so here you will see, we have two possibilities. Either alpha is less than beta, according to this, and either according to this, beta is less than alpha. So either we have this possibility or this possibility. Third possibility is like a constant function, but we have not taken that. We are assuming either this possibility, increasing function or decreasing function. Fine. So let us see, here we have assumed increasing nature. That means alpha is less than beta. So here we have taken either this or this. So we have assumed this possibility, alpha is less than beta, corresponding to this figure. Fine. So here we have assumed alpha is less than beta. So obviously we have selected this part. So according to, you will see that this interval alpha to beta is the subset of a to b. So that's why alpha beta is subset of a to b, closed interval a. Now function is continuous in this larger interval. So obviously function is continuous in the smaller interval a to b. This is also continuous in the smaller interval a to b, closed interval a to b, alpha beta, sorry. Then by the intermediate value theorem, f assumes every value between f of alpha and f of beta, because function is continuous in this small interval. So f function assumes every value in between alpha and beta, f of alpha and f of beta. This is by the theorem, intermediate value theorem, which we have proved earlier in the last lecture. Fine. That means f assumes every value between small m and capital M, because this is nothing but small m. According to this graph, f of alpha means this small m, f of beta means capital M. Fine, capital M. So f assumes every value between small m, which is nothing but f of alpha, and capital M, which is nothing but f of beta, according to this graph. Fine. Now from first says that f of AB is the collection of all the points of the form f of x, where x varies from a to b. Equation number 2 says that f of x is laying between small m and capital M. So this f of x is laying in between small m and capital M. So from 1 and 2 we can say that f of AB is basically subset of small m to capital M, closed interval small m to capital M. So this is the conclusion from 1 and 2. This is the conclusion that f of AB is subset of small m to capital M. This is now equation number 4. Because what is our purpose? Our purpose is to show that f of AB is equals to small m to capital M. So here we want to prove that f of AB is subset of small m to capital M, this closed interval, and f of AB is superset of small m, closed interval small m to capital M. We have already proved this part in equation number 4. Now we are trying to prove this part. Fine. So let us take a point from here and we will prove that that point will laying in this. हम एक पॉइंट यहाँ से लेंगे सपोज y, और हम प्रूफ करके दिखाएंगे कि ये पॉइंट यहाँ पर है. फाइन. सो लेट अस से y belongs to small m to capital M. That means here we have taken y here in this interval. Since function is continuous, so obviously there will be a point here c in the interval a to b such that f of c is equals to y. So since function is continuous, then by third and this intermediate value theorem, because this is f of alpha, this is your f of alpha, this is your f of beta, and from intermediate value theorem, f assumes every value between f of alpha and f of beta. So for this, there exists some c point here such that f of c is equal to y. This is by this conclusion. इस conclusion के according we can see that there exists some point c in the interval a to b such that f of c is equals to y. एक c जरूर exist करेगा ऐसा in the interval a to b such that f of c is equal to y. Fine. So this implies, but y is equals to f of c. That means this is nothing but what? This is a point of this form. This is a point of this form f of c. That means this y basically laying in this interval f of closed interval a to b. इसका मतलब जो आपका y है वो इस इंटरवल में लाई करेगा क्योंकि वो पॉइंट इस टाइप का है f of c. So this implies y, which is f of c, laying in this interval f of ab, and this is a random point of this interval. So this is valid for all y belongs to small m to capital M. That's why we can say that this interval, closed interval m to m, small m to capital M, is subset of f of ab. This is equation number 5. So from 4th and 5th we can say that f of ab is nothing but closed interval small m to capital M, which is nothing but a closed interval, and this is the theorem. So this is the preservation of interval theorem, closed interval. तो अगर कोई क्लोज इंटरवल है, कोई फंक्शन क्लोज और कोई फंक्शन कंटिन्यूस है, तो उसकी जो इमेज होगी वो भी एक क्लोज इंटरवल होगी. फाइन. नाउ अनदर वेरी इंपॉर्टेंट कॉन्सेप्ट इज यूनिफॉर्म कंटिन्यूटी. व्हाट इज द डेफिनेशन? सो बिफोर गोइंग टू डिस्कस द डेफिनेशन, फर्स्ट वी आर डिस्कसिंग द डेफिनेशन ऑफ कंटिन्यूटी. So by the definition of continuity of a function f at a point x naught belongs to capital I, this is the domain of the function. What is the definition of continuity at this point? For a given epsilon, there exists a delta greater than 0 such that f of x minus f of x naught is less than epsilon whenever x minus x naught, this magnitude, is less than delta. This is the definition. Now here important thing is that this delta basically depends upon this choice epsilon and the point x naught. So delta depends on epsilon as well as at point x naught. That is, delta is basically a function of epsilon and x naught. This shows the dependency. Delta depends upon epsilon and x naught. To show this dependency, we have taken one example. We have taken this function f of x is equal to x square for all x belongs to real numbers. Suppose we have taken the point x naught as 0 and epsilon is fixed as 1/4. तो हमने पॉइंट को फिक्स कर दिया, एप्सिलॉन को फिक्स कर दिया. नाउ वी आर ट्राइंग टू फाइंड आउट डेल्टा. अब हम डेल्टा को फाइंड आउट करेंगे. फाइन. सो नाउ टेक f of x minus f of x naught. This part, this is equals to what is function? Function is x square minus f of x naught, because x naught is 0. Put it here, so we get 0. So magnitude of x square. This can be rewritten as magnitude of x whole square. But we have, this is less than epsilon, and epsilon we have fixed as 1/4. So this is less than 1/4. So since this square is less than 1/4, so obviously magnitude of x will be less than half. This can be rewritten further as magnitude of x minus 0. अगर यहाँ मैं subtract कर दूँ 0 तो कोई फर्क नहीं पड़ेगा. This is less than half because our point is 0. That's why we have subtracted 0. This is actually our x naught. This is of this kind of equation. ये ऐसी equation है हमारी. So our point is x naught here, which is we have selected 0. So from this analysis we can say that when f of x minus f of x naught, because x naught is 0, so replaced here, f of x minus f of x naught is less than 1/4. This when x minus x naught is less than half, x minus x naught is less than half. This is basically our point 0 here, 0 here. Fine. Here is 0, here is 0. And this is our less than 1/2, this 1/2. And we have selected this as delta. This is by the definition of our continuity. तो यहाँ से हमें delta मिल गया हमारा half. So take delta as half. अब हम ये चेक करेंगे, we will try to check whether this delta works for every point. For example, here this delta equal to half works for 0. Now we are trying to find out whether this choice of delta and this choice of epsilon will work also for another point, say x naught is equal to 1, 2, 3 and so on. क्या उनके लिए भी work करता है ये? We will see this. Fine. So here delta equal to half works at point 0, x naught equal to 0 corresponding to epsilon is equal to 1/4. Fine. तो अब हम चेक करेंगे कि क्या ये किसी और पॉइंट के लिए भी वर्क करता है या नहीं करता. So now take different point with same epsilon. That is, say, suppose we have selected another point x naught equal to 1. Epsilon is same as it is 1/4. Delta is as it is 1/2. Now we will check this condition, whether this condition holds or not. This condition. If this condition holds for this choice of x naught is equal to 1, epsilon is equal to 1/4 and delta equal to half, then we will say that function is basic, this delta and this epsilon is works uniformly, otherwise not. Fine. तो हम चेक करेंगे कि क्या ये वर्क करता है यूनिफॉर्मली या नहीं. अगर नहीं करता तो फंक्शन कंटिन्यूअस ही रह जाएगा. सो नाउ टेक, सो हमने पॉइंट बदल दिया, यहाँ 0 की जगह 1 कर दिया. एप्सिलॉन इज 1/4, डेल्टा इज हाफ. फाइन. सो नाउ substitute this point in this definition, x minus x naught is less than delta. Substitute is there. So what we are getting, x minus point is 1, delta is 1/2. Now open this interval. So what we will get, minus half, x minus 1 is less than half. That means half is less than x is less than 3/2. We are getting this interval. That means x belongs to the open interval 1/2 to 1.5. Fine. So x belongs to this 1/2, that means 0.5 to 1.5 in this interval, and this is written here. Delta is half, point is 1, so we have written here. So we are getting this x belongs to 0.5 to 1.5. Now in this interval, take any point, suppose 1.4. 1.4 laying in this interval, so that's why we are taking x equal to 1.4. From this interval we have selected 1 point. Then x minus x naught is 1.4 minus 1, because x naught is 1, x is 1.4, this is 0.4, so obviously this is less than half, which satisfies this inequality. Now we will check the image part, f of x minus f of x naught. Function is x square. So 1.4 whole square is 1.96. Function क्या था हमारा, x square. So 1.4 whole square is 1.96 minus f of x naught, which is 1 whole square is 1. What is our function? Our function is this, x square. So substituted is here, f of x 1.4 whole square, 1 whole square, so 1.96 minus 1. Difference is 0.96, but this is greater than epsilon. This epsilon 1/4. So that's why our definition of continuity fails here. इसका मतलब हमारी definition जो है वो यहाँ पर fail हो गई इस choice के लिए. डेल्टा हाफ के लिए हमारी इस चॉइस के लिए ये वैल्यू, ये डेफिनेशन फेल हो गई, बिकॉज दिस इज ग्रेटर देन 1/4, नॉट लेस देन होना चाहिए था, बट ग्रेटर आ गया. फाइन. दस गिवन एप्सिलॉन ग्रेटर देन 0, द सेम वैल्यू ऑफ डेल्टा डज नॉट वर्क फॉर डिफरेंट पॉइंट्स ऑफ द इंटरवल. फाइन. इसका मतलब ये डेल्टा हर एक पॉइंट के लिए वर्क नहीं करता, ये 0 के लिए वर्क करता है, बट दिस विल नॉट वर्क फॉर 1. So if a continuous function f is such that given epsilon greater than 0, we can find a uniform delta. Here is the important point, is uniform delta, which depends only on epsilon and not on the point x naught, at which the continuity is considered. Then we say that f is uniformly continuous. अगर हमारा एक एप्सिलॉन के लिए जो भी हमें डेल्टा मिलता है वो सबके लिए वर्क करे यूनिफॉर्मली, देन वी कैन से दैट फंक्शन इज यूनिफॉर्मली कंटिन्यूअस, otherwise continuous only. Fine. So here definition is a function f defined on an interval capital I is said to be uniformly continuous on closed interval I if given epsilon greater than 0 there exists a delta which depends on epsilon only and not only delta. अब आप देख सकते हैं ये जो है डेल्टा केवल एप्सिलॉन पे डिपेंड है, ना कि पॉइंट एक्स नॉट पे. एक्स नॉट पे उसकी कोई डिपेंडेंसी नहीं है. सो डेल्टा इज अ फंक्शन ऑफ एप्सिलॉन ओनली ग्रेटर देन 0 सच दैट f of x1 minus f of x2 here both are variable. However, in continuity one point is variable, for example here, and this is a variable quantity, this is fixed quantity. What is the meaning? So here, so f of x1 is a variable quantity, f of x2 is another variable point, their difference is less than epsilon whenever x1 minus x2 is less than delta. Here x1 and x2 belongs to I. तो फ़र्क क्या हुआ? फ़र्क ये हुआ कि अब दोनों वेरी करते हैं, पहले ऐसा नहीं था. What is the definition of here continuity? Continuity says that f of x minus f of x1 is less than epsilon when x minus x1 is less than delta, and here delta is basically a function of x naught and epsilon. This is continuity. This is fixed point. This is a variable point. Fine. Now uniform continuity. Definition says that f of x1 minus f of x2 is less than epsilon when x1 minus x2 is less than delta. Almost similar difference is that here f of x1 and f of x2 both are variable quantity, not fixed point, and here delta is a function of epsilon only. Here is a function of x naught and epsilon, here the function of epsilon only. That means delta does not depend on this x naught. Fine, does not depend on x naught, that's why both varies, दोनों वेरी करते हैं. Fine, this is the difference. I hope you understand the difference between continuity and uniform continuity. Now we have three note points. Number one, uniform continuity is a property associated with an interval and not with a single point. यानी ये प्रॉपर्टी जो है वो एक इंटरवल के लिए है, ना कि किसी सिंगल पॉइंट के लिए. फर्स्ट इंपॉर्टेंट पॉइंट. However, continuity is associated with a single point. Function is continuous at a point. Uniform continuity means function is uniformly continuous in an interval. Fine, this is the difference. Second, uniform continuity is a global property of a function, while continuity is a local property. Local means continuity, function is continuous at a point. केवल एक पॉइंट पे कंटिन्यूस हो सकता है. हाउएवर यूनिफॉर्म कंटिन्यूटी इज अ ग्लोबल प्रॉपर्टी, दैट मीन्स एक पूरे इंटरवल में होगी, बड़ा पार्ट ग्लोबल. लोकल मीन्स छोटा, स्मॉल. फाइन. थर्ड, इफ फंक्शन इज नॉट यूनिफॉर्मली कंटिन्यूस, if function is not uniformly continuous on the interval I, that means if there exists some epsilon greater than 0 for which no delta found. कोई ऐसा एप्सिलॉन आपको जरूर मिल जाएगा जिसके लिए वो कोई डेल्टा आपको मिलेगा ही नहीं, तब हम कहेंगे कि फंक्शन यूनिफॉर्मली कंटिन्यूस नहीं है. दैट मीन्स फॉर एनी डेल्टा ग्रेटर देन 0 देयर एग्जिस्ट 2 points x1 and x2 belongs to I such that f of x1 minus f of x2 is greater than equals to epsilon and x1 minus x2 is less than delta. Both these points laying in in the range, however their images will be outside the range, outside the domain, this epsilon. This magnitude of this is greater than equal to epsilon. Fine. If this is less than epsilon, then we will say that function is uniformly continuous. But if here greater than equal to epsilon, so function is not uniformly continuous. Fine. So this is the uniform continuity. So now we will take the theorems based on this uniform continuity in the next video. Thank you.